All right, we're going to finish with the last part of 5.7, which is looking at an algebra technique that probably is not one you use very often. It is looking at completing the square. To be honest, I'm not a huge fan of completing the square in algebra 2, but I actually find it to be very helpful in calculus. And what you'll notice is you may remember some of the completing the square from algebra 2 were kind of complicated. These are definitely looking at the most basic examples of what you would have done. So here's how completing the square works. You're trying to come up with a perfect square trinomial so that you can write it as a binomial squared. So you take your middle term, which is often called the b term, and you cut it in half and then square it. So half of 8 is 4, 4 squared is 16. And that allows us to write it as x plus 4 squared. That's that perfect binomial. If it's subtraction, we don't change anything about the squared. So we take half of 16, which is 8, squared is 64. But when I write it, I'm going to write it as a binomial with subtraction because that middle term was negative. And then the last one, half of 18 is 9. 9 squared is 81. So we can write it as x plus 9 being squared. So here's how this shows up. We end up using this always with arctangents. So these are always inverse tangent, which is another reason why arctangent is probably the most common inverse trig to show up. What you're going to notice is you have a denominator that is a trinomial. It's not going to be a perfect square to start with, and you can't do a regular u substitution. So what you're going to do is take your first two terms and figure out what do you need to complete the square. Well, half of 2 is 1. 1 squared is 1. So you need 1 to complete the square. You started with 2. So you basically borrow one of those, and then you have 1 left over. So we can rewrite this as the quantity x plus 1 being squared plus 1. It is now in a perfect inverse tangent form. Your a is what was squared to get 1. Your u is x plus 1. It's a binomial. And your du is just dx, or 1, so no adjustment. So your integral is 1 over 1, which doesn't need to be written, arctangent of u over a, which ends up just being the arctangent of x plus 1. Same thing with the next one. You're going to take the first two terms and figure out what you need to complete the square. Half of negative 4 is negative 2. Squared is 4. I had 7 to start with, so 4 of them are needed, which means 3 are left over. So I can rewrite this as x minus 2 being squared and then a plus 3. Again, you notice how it's in that nice arctangent form. Your a is not a whole number. It's the square root of 3, which is fine. Your u is x minus 2, and your du is just 1, or dx, so no adjustment. So you get 1 over the square root of 3, arctangent of x minus 2 over the square root of 3. You do not need to rationalize that, and you leave it. So that's one of the only special cases you'll see. It's not super common, but it does kind of show you again how algebra helps the calculus.